Hello and welcome to my video, lesson 9.6 on second degree trig equations. Alright, so we've learned a little bit about trig equations in the last video. We understand also the idea of the general form, which I'm going to put a video in between the last one and this one about general form, maybe even before the last one. I'll do a separate video on that as well, just to get into more depth. But we're going to take a look at some questions here and solve these using factoring and really thinking about these second degree equations. Also, on top of that, we're looking at using different trig identities in order to solve these. So always when you're doing trig identity questions, you always should have your formula sheet next to you, because you're going to be looking back and forth. I don't want you to memorize these, but you're looking back and forth to look for patterns. And so what I am doing here on this first question is I'm seeing and noticing this pattern here. This is a cos 2x. This is a double angle identity. So we have to look on our formula sheet and pick one that will work with our question. Now, given the fact that we already have cos x, I'm going to guess that we want to have a cos x option. So I'm going to, instead of the part I just had in red, I'm going to keep the rest of it all the same. But instead of that part in red, I'm going to write down one of my identities. The identity I'm going to use is 2 cos 2 squared x minus 1. In your formula sheet, this is cos squared, and then instead of x, it's alpha, but it's the same thing. Okay, now that we have that, now we can go ahead and really rearrange and solve this. So this is going to be 2 cos squared x minus cos x. The plus and minus 1 are going to cancel, and it equals 0. Now we can go ahead and factor out a common factor of cos x. So it's 2 cos x minus 1 equals 0. So this is our first example we're doing. And we can hopefully see, just like in algebra, if this part is equal to 0, then the whole thing is 0. Or if this part is equal to 0, then the whole thing is 0. So we get to just pick one to do first. Let's look at the simple one. Cos x equals 0. If this equals 0, then the whole answer is 0. So what I'm going to recommend you do is you draw a little unit circle beside in order to solve this. So where is cos x equal to 0? Well, it's whenever x is equal to 0. So that's up here and down here. So these are both the locations where cos x equals 0. So that means x equals pi over 2 and 3 pi over 2 if we're talking about radians. So let's look at the next part. So in purple, we've got 2 cos x minus 1 equals 0. Now we're going to move over the 1, and then, you know what, I'll just divide by 2 right away. Hopefully you guys are okay with that at this point. So x equals, so when is the x value around the unit circle 1/2? Well, it's going to be the shorter one, so it's going to be over here and over here. So those are going to be pi over 6 and 11 pi over 6. So we have 4 possible answers, but now we're going to read the question again carefully, and it has a domain restriction for us. So these are the ones that I've listed between 0 and 2 pi, but if we're going all the way to 4 pi, that means we could wrap around our unit circle an extra time. So we're going to go 1 time all the way around, that's 2 pi, and then, whoops. So all the way to here is 2 pi, and then all the way around 1 extra time, that is 4 pi. There you go, 4 pi. So you'll notice that it hits each one of these twice. So we just have to add 2 pi to any one of these to get the next sets of answers. So this is going to be 5 pi over 2 and 7 pi over 2. These ones are going to be 13 pi over 6 and 23 pi over 6. So our final answer includes all 8 values. Okay, I recommend you pause the video now and try the next question on your own. Okay, so same process for the next one. Again, you're going to hopefully notice that this part is a double angle identity. So we're going to write the rest of it out. But we're going to put in the double angle identity in red, which is 2 sine x cos x. Yes, so from there, what we can do is write this out again, but without the brackets. Whenever we substitute in, I really strongly recommend you put the brackets in first and just take one extra step. It takes a tiny bit of time, but it saves you so many troubles. Okay, so anytime you substitute, do like I just did. So now we're going to take out the cos x, again, greatest common factor, but now it's 2 sine x minus 1 equals 0. So it's the same process as the last question. So cos x equals 0. So x equals pi and, oh, not pi. We're not going to do pi. We're going to do 90 degrees and 270 degrees. We'll figure out in this domain in a second. Okay, and then the other part, we're doing 2 sine x minus 1 equals 0. So it's going to be sine x equals 1 over 2. So similar sort of idea, except this time, so the green still goes up and the green still goes down, but the purple is going to be sine, where sine is positive, and sine is the shorter one. Aha, I made a mistake on the last one. This was my mistake. If you caught it, good work. Cos is the shorter one, which is x being the shorter one. So these are all going to be just slightly different. So this is going to be pi over 3, and then it's going to be 5 pi over 3. And then this is going to be 7 pi over 3 and 11 pi over 3 for the last one. This one, the one with sine here, is going to be the ones that I had before, which were the 30 degree and the 330 degree positions. Now, in this question, it says it's going from negative 360 to 180. So if it starts here at negative 360, goes all the way around and goes to here. So this position here is the 0. So that means that 330 is not going to be included. 270 is not going to be included. Okay, but we can go in reverse. So if we go in reverse, it's going to be negative 30 degrees and negative 330 degrees. And then for the green ones, it's going to be negative 90 degrees and negative 270 degrees. So there's a total of 6 answers that are required for this question. Okay, sorry about the error on the first one, but hopefully that makes more sense. Let's go ahead and try some additional questions. So I think we're going to be able to do this, no problem. We're going to go ahead and try it out. So what are you going to notice here? Hopefully, like I said before, you look for patterns. So here's a pattern. And actually, you know what? Better yet, here is a pattern. Using Pythagoras, the Pythagoras identity is that sine squared x plus cos squared x equals 1. But if we move that around, that's sine squared x equals 1 minus cos squared x, right? So what we can do is replace this part with sine squared x. So that's what we're going to do here, sine squared x. The rest of everything stays the same. And now we can solve for x. So this is going to be sine squared x minus, and we're moving everything over. The reason is the same as when we do it with algebra. If we get equals 0, we can do some amazing stuff with it. For example, we can do PSA. So PSA tells us, and we'll use different colors so we can keep that straight. The product is 2. The sum is -3. So we need two numbers that multiply to get 2 and two numbers that add to get -3. So 2 and 1, 2 and 1 both work, but we need it to be double negative, and then we can get our answer. So with that said, our answer is going to be sine x minus 2, sine x minus 1, and those equal 0. Okay, so now what we can do is we can say, well, this part here is sine x minus 2 equals 0, because if that part equals 0, then the whole thing is equal to 0. So sine x equals 2. And now the other part is very similar. So sine x minus 1 equals 0. So sine x equals 1. So what you'll notice here, hopefully, is that if we go around the unit circle, is there ever a time where sine x equals 1? Well, where y equals 1? Yeah, certainly. That's up here. That's going to be over that spot. So x equals, and then, you know, it doesn't say, but I'm going to use radians unless otherwise told. So we'll go with that. But is there ever a point where this is true? No, if you type that in your calculator, you're going to find that it's an error. Why is it an error? Because sine is opposite over hypotenuse. And this is saying 2 over 1. Well, why is that a problem? You know from junior high that the hypotenuse must be the biggest side. So the 1 must be, or the denominator must be the biggest. And it's not in this case. That's why this will not give us a value of x. So actually, there's no way for this term to become a 0. There's no way for that bracket to become a 0, which means there's no actual value of x here. It does not exist. There's no value of x that will result in sine x equal to 2. So the only value, the only answer is pi over 2. Now, this is asking for a general solution. So if there's just one answer, this is going to be nice and easy. What happens is you just see it hit over and over and over again. Every time you spiral around the circle, it's just that pi over 2 plus a period every time. Now, it's every time, so we use k, where k is an integer. So this is our general form solution. All right, I recommend you pause the video now and try the next one on your own. Okay, let's go ahead and try this one now. So what we're going to do is same sort of thing as before. We're going to try to look for a pattern. Now, in this case, the pattern is this one. It's the reverse of the last one. So it's 2 cos x plus, and then instead of all that, I'm going to write cos squared x equals 3. Very, very similar to the last one. So all I'm going to do is just rearrange this a little bit so that my highest degree term is first, just like we're used to with quadratics. Okay, it looks like that. Now we can go ahead and PSA factor it. So PSA, the product is -3. The sum is 2. So it's going to be 3 times -1, 3 plus -1 as our two numbers. So now what we can do is plug that into a set of brackets. So it's cos x plus 3 cos x minus 1 equals 0. So just like before, cos, we can do the same sort of thing as before. This part in purple is going to be cos x plus 3 equals 0, cos x equals -3. And again, like before, what we're saying here is it's -3 over 1 and adjacent over hypotenuse. Well, that's not going to work because, again, the hypotenuse is not the longest side. So this one does not give us an answer. So that means x from this one, x does not exist. So let's go ahead and try it on the next one. So this is cos x minus 1 equals 0. So it's cos x equals 1. So where does that happen on the unit circle? Well, it happens wherever cos is 1 or x is 1. So it's going to be right over here, which happens when x is 0 or 2 pi, right? So we can make this a very simple statement. X equals 2 pi, and then it happens every 2 pi where k is an integer. All right. I hope that helped. Now, we're going to try a slightly different one. This one has a secant. So when we see a secant, we should look for that, because if you ever see a reciprocal function, you know it's going to have a certain pattern. So this is 3 cos x plus 2 equals 5 secant. So secant is cos x. So how can we solve this? Well, we're going to multiply both sides by cos x. So it's going to be 3 cos squared x plus 2 cos x equals 5. Now we can move the 5 over. And so we're going to end up having a PSA 2 type question. So now this is PSA 2, PSA. The product is going to be -15. The sum is going to be 2. So that -15 came from 3 times -5. And then we have to get two numbers that multiply. So it's going to be 5 times -3 and two numbers that add. So 5 plus a -3. Yeah, like that. Now we can take those two values and plug them back in to these to this expression as the middle term, i.e. we're decomposing this middle term here. So it's going to be 3 cos squared x plus 5 cos x minus 3 cos x minus 5 equals 0. Now we can do a GCF on both parts, so a GCF here, and critically a GCF here, including that negative. So we're going to put a little plus in between. So we're taking a GCF here now. So the first one is just going to have a cos being taken out, cos x. So it's going to be 3 cos x plus 5. The second one is going to have a negative 1 taken out of the brackets. That's it. So 3 cos x plus 5 equals 0. So now we have those two options, and we can write it as 3 cos x plus 5, because both those things in the brackets are the same. Therefore, we're GCFing them out to the left side and then getting the leftover parts inside. Okay, so all that to be said, we are resulting with these two results. So we get 3 cos x plus 5 equals 0, because if that part equals 0, the whole thing equals 0. So now we're going to subtract by 5 over. Then we're going to divide by 3 over. And again, hopefully you can see that once again, the hypotenuse is smaller than the adjacent, which is impossible. So x does not exist here. Let's try the second one. So cos x minus 1 equals 0. So cos x equals positive 1. So where's cos positive 1? Well, you can look at it again at the one above. So it's at 0 or 2 pi. And so we're going to use x equals 2 pi k, where k is an integer. All right, let's continue on with the next one. I recommend you pause the video now and try the next one on your own. Okay, so same sort of process. What are we looking for? We're looking for this weird, anytime we have a weird reciprocal. So we're going to go 2 sine x equals 7 minus 3. And then instead of cosecant, I'm going to write 1 over sine. So actually, I'll just do it as 3 over sine x. So let's move the 7 over. Let's move the 7 over. So 2 sine x minus 7 equals negative 3 over sine x. So now we can multiply both sides by sine x. So it's 2 sine squared x minus 7 sine x equals negative 3. Now we can move that over. So 2 sine squared x minus 7 sine x plus 3 equals 0. Just giving myself a little bit more space. So now we're going to PSA on this guy. Now, if you can, I'm okay if you skip ahead. So I'm going to do that myself here. This is going to be a 2 sine x, because that's a prime number. Then I know that one has to be a 2, one of them has to be a 1. The result is a 3, so they're both going to be positive or both going to be negative, and they're both going to be negative because the middle sum is negative. So it's going to be a 3 and a 1, so I'm going to put a 3 and a 1 here because it looks like the 7's pretty big. 3 times 2 is 6, plus 1 is 7. Yeah, I got it. So you can kind of skip through it if you want, or you can do PSA 2 like I did in the last one. I'm okay if you just show your work as I've just done here. So based off of that, this statement is 2 sine x minus 1 equals 0. So sine x equals 1/2. And that's great because the hypotenuse is definitely less. But this statement here is sine x minus 3 equals 0. So that means sine x equals 3, which we know is a problem. So here, x does not exist. So we just look at the purple answer. And as we looked at before, we want to look at where sine x is a 1/2. That's going to be in these two positions. So that's like the pi over 6 position. So pi over 6 and also 5 pi over 6. Now, given the fact that we're looking for a general solution, we're going to have two different statements. So it's pi over 6 plus 2 pi k, where k is an integer. The other one is going to be the same sort of thing, 5 pi over 6 plus 2 pi k, where k is an integer. So both of those are possible solutions. Okay, and I believe these are the last two questions for this video. So the only difference here is that we've got some quotient quantities. So let's get rid of this one first because I know that that one's annoying. And we'll see if that's enough. So first of all, this is going to be cos x over sine x. And the other side is sine x. So the nice thing is these guys just straight up cancel. And so what we can do is just look for those values. So cos x squared equals cos x. And now we can move that over. So it's going to be cos squared x minus cos x. And so we can take out a GCF of cos x. So cos x minus 1 equals 0. Okay, just like before, we can look at the different parts. So this part here, cos x equals 0. So just like before, we'd look at this part here, and it says cos x equals 0. And then we can look at the other part here, and we can see that cos x minus 1 equals 0. So cos x equals 1. So we look at our unit circle and try to solve for the different situations. So where cos is 0, that's going to be over here. Sorry, that's wrong. That's going to be here and here. Where cos is 1 is going to be here. So we've got three different solutions. So x equals pi over 2 plus, sorry, not plus, or 3 pi over 2. For x, we have it at 0 or 2 pi. So we're going to have two different statements. So for the green one, we're going to say 2 pi k, where k is an integer. For the blue one, we can actually combine these, which is awesome because they are 180 degrees apart. So we can say pi over 2 plus pi k. Notice that that's not one full period, it's half a period because it's rotating every like 180 degrees or every pi, where k is an integer. Okay. So you can go ahead and try this on the next one and see if you get the same answer I do. Okay, so same sort of process. We've got sine squared x equals 1/2, and then tan is sine x over cos x. Now, again, this is a cos x over here, so the nice thing is those guys cancel. Okay, which means we can actually just move this over. So sine squared x minus 1/2 sine x equals 0. I'm going to make this a more clear equals. Okay, now we can take out, as in a GCF, of sine x. Whoops, not squared, minus a half equals 0. Okay, and just like before, we can look at the different parts. So let's look at this part is sine x equals 0. The other part here is sine x minus 1/2 equals 0. So sine x equals a positive 1/2. So again, if we look at our unit circle and how that will appear, wherever sine x is 0 is where y is 0. So that's going to be over here and over here. Wherever sine x is 1/2 is going to be where the y value is 1/2. So it's going to end up being here and here. So in purple, we have, did I do cos 0? Yeah. In purple, we have 0, pi, and 2 pi. In green, we have pi over 6 and 5 pi over 6. So if we look at the purple answer, we get x equals, and we can take the pi and use it as our fun thing that always repeats. Because every pi degrees, it hits one of those purple sides, and it covers both. So this is part of our answer. Okay, in green, we have x equals, let's give it a little bit more space here. X equals pi over 6 plus 2 pi k, where k is an integer. And we have x equals 5 pi over 6 plus 2 pi k, where k is an integer. All right. I hope that this helped you a little bit with second degree, especially PSA, PSA 2 questions with regards to trig equations. I hope the video helped, and good luck.